Namaste. Today we will have a look at volume tables. So, coming to the slides, what is a volume table? A volume table is a table that shows volume for a given species for single or multiple dimensions, and those dimensions can be the diameter at breast height, dBH and height, dBH height and taper, or any other parameters. So, essentially, as we have seen in this course, if you have a tree and you are interested in knowing the volume. So, we know how to measure the dBH. If we know the dBH, then we can find out the basal area, that is given by pi by 4 into d square, if dBH is written as d. What is the volume of the cylinder? That will have a basal area equal to that of the tree and height that is equal to that of the tree. The volume of the cylinder will be given by pi by 4 d square into h, where h is the height of the tree, and the volume of the tree is given by form factor multiplied by the volume of the cylinder. So, this is something that we have already seen in this course, and there are a number of methods of finding out the volume of the tree. So, for instance, we could divide our tree into a number of sections and then measure the volume of each section, or rather calculate the volume of each section by taking its diameters at the two ends, or say its center diameter and the height of the section or the length of the log, and we can total up all those volumes to give us the volume of the tree. Now, if we wrote this equation, it becomes f into pi by 4 d square h. So, what all things do we require to find out the volume of the tree? We need to know the f. F is the form factor that is given by the taper of the tree. So, for instance, if this tree had a bole that was completely cylindrical, its form factor would be 1. If its bole was in the form of a cone, then the form factor is 1 by 3. So, depending on its taper, we will have a value of f. We also require the value of d, which is the diameter at the breast height, and we also need to know the height of the tree. So, essentially we can say that the volume of the tree is a function of the form factor, the diameter and the height. So, if we know this function completely, then if we knew the form factor, the diameter and the height, then we would be able to know the volume of the tree. However, when you go into the field situations, when you look at a number of trees, so all those trees will be having different diameters, different heights, and maybe even different tapers. So, for instance, we have already seen in this course that you can have a eucalyptus tree that has a very cylindrical bole, or you could have another eucalyptus tree that is extremely branchy. So, it has a number of forks. So, these two trees can be the trees of the same species, say in the case of eucalyptus. And what would determine whether your tree has this shape or whether it has a forked shape? Well, we have looked at Metzger's theory, and we know that if our tree is right in the center of a forest and it is not suffering a huge amount of wind pressures to sway it on its sides, so in that case it will have a roughly cylindrical bole, whereas if you have an isolated tree and that is suffering a huge amount of wind forces, then it will go on accumulating mass at the bottom to give it a taper. Also, when you put your tree in isolation and it is suffering a huge amount of wind forces, it might acquire the shape of a fork, or maybe this forking shape came out because of some interaction between this tree and its environment. So, maybe there was some insect attack or maybe some disease that led to any epicormic growth. So, all the trees in your forest stand will be different. So, if you wanted to find out the volume of your trees using this formula, you will have to measure the form factor for every tree, the diameter for every tree and the height for every tree. Now, is there any way of simplifying this? So, why do we want to go for a simplification? We want to have a simplification because measurement of all these things for every tree becomes very tedious, and at the same time we do not want a very high level of accuracy and precision in this case, because wood is not a very expensive material. So, for instance, if your tree were made out of gold, so you would want to know every single milligram of the tree and you would want to calculate it completely exactly. But in the case of a tree whose price may be say around 30,000 rupees or even say 15,000 rupees per cubic meter, whether it is 1 cubic meter or whether it is 1.05 cubic meter, it is not very life and death situation. So, you can have some amount of flexibility when you are measuring these values. So, if we go back to this equation, is there any way of simplifying it? So, for instance, if we took a tree and if suppose we measured its diameter and its height, how would that grow like? So, in the beginning this tree might give a small increase in height, then it might grow exponentially in height, and then this height might even flatten out. So, for instance, if you go into a very dense forest, then your trees might not be showing any further growth in height even though its diameter is increasing. So, if we knew this, if we were able to find out an average curve that gives us heights for different diameters. So, in the equation your volume of the tree is a function of form factor, the diameter and the height. We could replace this height with some other function of the diameter. So, that would become h is equal to some other function of the diameter. So, in that case your volume of the tree will become some other function of the form factor and the diameter, because you are now considering the height as a function of the diameter. Now, at the same time when you go inside a forest, so if we are not considering the edge effects, so suppose you have a number of trees in the forest, so if you consider one location, then there might not be a very great difference in the form factors of all these trees, because essentially if all these trees have been subjected to the same soil, to the same environmental conditions, maybe to the same levels of attacks by say pests or insects or diseases, if all these trees are of the same species and they are all having the same surroundings and probably the same age. So, in that case there might not be a very huge difference in the form factors of all these different trees. So, when we write that the volume of the tree is a function of the form factor and the diameter, so for a given locality, for a very small area, we could even say that the volume of this tree is some other function of just the diameter itself. So, what we have here is that the volume of the tree is a function of form factor, diameter and height, or some other function of just the form factor and the diameter, or some other function of just the diameter. So, we can simplify these equations, but when we do this, then we will be reducing the amount of accuracy that we have. So, this equation is the most accurate equation and this equation is the least accurate equation. So, depending on what we want to do with our trees, we might be good with a less accurate equation as well. So, now coming back to the slides. So, it says that the volume table can give you the volume in terms of just the diameter at breast height. So, coming to the tablet, this would be the equation. So, it is giving you the volume of the tree just as a function of the diameter. Now, back to the slides, or it could give you, so you can even write it as another function that is just based on the diameter and the height, because you could say that for any site f would be a constant if we are considering a very small locality. So, for instance, here we said that when all these conditions are the same, then we can say that f is constant for all these trees. So, we can even remove the f and just write it as a function of diameter and height. So, moving back to the slides now. So, here it says that it can give it to you in the function of just the diameter and the height, or the diameter, height and taper, or any n number of factors. So, accuracy increases with the increase in the number of dimensions. So, for instance, if you measure it just with the DBH, it is the least accurate, and if you measure the diameter, height, taper and maybe some other factors as well, it might, the accuracy will increase. Now, in the case of a volume table, the volumes that we are getting on this table are average values. So, they might not correspond to each and every tree, but they are an averaged out value, because we want a quick estimation. So, for instance, if you are in a forest and you wanted to have a very accurate and precise measure, so in that case you will chop down your trees, you will cut them into sections and maybe measure each and every section and then sum up those volumes to get the exact volume of every tree. But if you wanted to have a quick computation, you could take an averaged out value. So, coming back to the slides, when we talk about volume tables, you can have different kinds of volume tables. So, some of those are given on this slide. So, you could have a volume table for the commercial timber by full basal area. So, here what you are considering is commercial timber. Commercial timber is the timber that you are extracting out of the forest to be used commercially. You could even have another table for sawn timber. So, for instance, when you have a tree and when you are putting it through the sawing operations, then as we have seen before, in the cross section, because we want to have sheets of the log, so in that case we might be losing out on the D's, as we have seen in the quarter girth formula. So, we will be excluding these. So, we can either calculate the whole volume and then find out the volume of the sawn timber to be some factor f the volume of the log. So, in the case of the quarter girth formula, we calculated this f to be 78% approximately. So, we can either write it as a fraction of the volume of the log, or we can directly multiply all the values of volume of the log with this factor and directly note down the volumes of the sawn timber. So, coming back to the slides. So, this is what it says, that you can even have a table for a sawn timber. You can even have a local volume table. Now, what is a local volume table? A local volume table gives you the values for a given locality. It is not a generalized value that you can use everywhere, but say if you want to consider the forests of say Dehradun, then maybe a very small area. So, for instance, a forest of Timli might be having very similar values. So, you can derive a local volume table for that. Now, coming to the slides, you can even have volume tables based on site quality. So, site quality tells you how fertile a site is. You can have the volume of stem timber in round excluding bark. So, you can find out the volumes including the bark or excluding the bark. So, there it was excluding the bark. Now, you can have volume of the stem, small wood and branch. So, in this case, when we are considering a tree, so in this tree we can find out the volume of the main stem, or we can find out the volume of the branches, or the volumes of even smaller branches. So, which is what it says in the slide, volume of the stem, small wood and branch in round including the bark. So, when we are saying in round, it is not a sawn volume. Or you can find out the volume of branch timber in round excluding the bark. So, in this case we are just considering what volume we can extract out of the branches. So, maybe they could be used as fuel wood. So, depending on your applications, you can have different kinds of tables, or you can even have volume of branch wood and stem wood including the bark, because even if there is bark you can burn it. So, that is good in terms of your fuel value. Or you can have volume of commercial timber in round, volume of sawn timber, or you can even have a table for the deductions for bark that you can make if you have the other values. So, essentially we can have different kinds of volume tables. And if you looked at a table of the volumes, so this is a book that tells us the growth and yield data for forestry species of the plains of India. So this book is colloquially called as the volume table book or the yield table book. So if we look at one particular species, say the species called Shorea robusta, which is sal. So if we look at the volumes of sal, so this table gives us the commercial timber in the round, and the volume is calculated by the full basal area. So if you looked at this table, here it shows us different diameter classes in centimeters. So this is 20 to 30 centimeter dia class, 30 to 40, 40 to 50 and so on. And then on this side we have the height of the tree in meters. So you can have 12 meter high tree, 18 meters high tree, 19 to 24 meters, 25 to 30 meters and so on. So for each of these categories, for say this diameter class 30 to 40, if you have a tree that is in this height class of 19 to 24, the volume in cubic meters is 0.453. So all these things have already been calculated for you, and you just need to match the columns and the rows to get the values. So this is one table that gives us for Shorea robusta the commercial timber in the round. Now this is another table that gives us for Shorea robusta, it gives us the sawn timber in a normal good coop. So it is saying that it is a normal coop. So coop is an area in which you are performing felling operations and you are extracting that timber out of it. So it is a normally good coop. For that coop, if you want to find out how much is the volume of the sawn timber that you will be that you can extract from a tree of this diameter class and this height class, then you can get it from here. So for instance, for the same dia class and the height class 30 to 40 and 19 to 24, it says 0.212. Now earlier we had the value of 0.453 and this one says 0.212. So which tells us that roughly we will be able to extract half of the volume in the sawing operations. So let us look at another table now. Now this table shows us for Shorea robusta, this is a local volume table, that is site quality wise. So here as well we have in this diameter class, so we are only measuring the diameter and we are measuring the site quality. So site 1 is the best site, 2 is a little worse than that, 3 is a little more worse and 4 is the worst or the least fertile soil. So if we just are measuring this diameter class values, so for say 30 to 40, you can have different volumes in a full grown tree. So this is a local volume table. You can have also another kind of a table that gives you the values only for the locality or the site quality 1 and 2. So this one gives you that for this diameter class, if you wanted to look at the stem length of the commercial bowl, then in the site 1, so if you consider this 30 to 40 centimeter diameter class, in the case of a site 1 quality area, the stem length of the commercial bowl will be 16.46 meters, but in the case of site 2, it will reduce from 16.5 approximately to 13.1. So the length of your commercial bowl will reduce. So essentially it tells you how much is the length of your commercial bowl. So that is the point till which you will perform your cutting operations. It will also give you the stem commercial timber in round. So this was in meters, you can even have the volume values in cubic meters. Then you can have the sawn timber, that is an absolutely sound straight bowl. So these are different qualities of wood, so it can give it to you in the terms of its volume. You can even have the stem sawn timber in the normal good coop in cubic meters, stem sawing factor and the addition for branches. So that is a volume that you are going to add to number 4 and 5 volumes. So this is another local quality volume table. Another table, this table 5, it gives you the volume of stem timber in round excluding the bark. So all these tables are arranged in a similar fashion. So you have your length of the commercial bowl or the height of the tree in this first row, and here you will have the diameter classes, and for all of these you can you will be able to measure the volumes here in the table. So, now coming back to the slides, if we now looked at the types of volume tables. So, here we had a different volume tables, but how do we classify them? So, if you looked at the classification of volume tables, the first classification is based on the number of variables that you have. So, for instance, a single variable, say your diameter at breast height, it will have limited use. If you have two variables, say diameter and height, or diameter and the form factor, or form factor and height, it will have a bit more usage. If you had multiple number of variables, the diameter, the height, the form factor, the site quality and so on, then it might have much more usage, especially in the case of research. As per the scope of application, you can have a general volume table, a local volume table, or a regional volume table. This general volume table is the most generalized table. So, it will have all your variables and it will be giving you all sorts of values. You can use your general volume table to derive a regional volume table or a local volume table. So, if you looked at the differences between these between your general volume table and the local volume table, here are the differences. So, the general volume table gives you three quantities. So, it will have height, diameter and the volume, whereas a local volume table will only give you diameter and volumes corresponding to those diameters, because we are considering that for this localized region the height is a function of diameter and that has already been put into the volume values. So, your general volume table can be used for larger areas, whereas local volume table, as its name suggests, it can only be used for a small localized area. The general volume table has a limited application. It is very useful in the case of research purposes, but because if you want to use your general volume table, you have to measure these two values, height and diameter, to get the volume. So, it has limited application in the field situations, whereas a local volume table, because it in this case you only have to measure one value of diameter, so it has more field usage. The general volume table is used to derive the local volume table, and the local volume table is derived from the general volume table. Your general volume table is prepared from felled trees, because in this case once you have cut your trees, you measure all the variables that you can find out, and then measure the volume with all the sections to get your general volume table. But because your local volume table is derived from the general volume table, it can be prepared from standing trees as well, because you only need to measure the diameters, and you can always get the volume from your general volume table considering the heights. So, it can be prepared from standing trees and the general volume table. Now, general volume table is less precise for your field applications, whereas a local volume table is much more precise. So, that was another way of classification. Another classification, or the third classification, is on the basis of the outturn. So, outturn tells you what are you trying to measure or what are you trying to get out of your volume table. So, you can your outturn could be the standard round timber, the commercial round timber, the sawn outturn, assortment, or so on. So, that is what we already saw in the case of the book. So, how do we prepare these volume tables? So, there are two methods of preparation of volume tables. One is called the graphical method and the second is called the regression equation method. So, when we are trying to prepare our volume tables, we are trying to get the volumes in a tabular form, such that if we know the measurements of one parameter or two parameters or three parameters, we should be able to get the volumes. So, in the case of general volume table, we will be measuring the diameters, the heights and the volumes, and then use them in a tabular fashion. So, this table can be generated either by the graphical method or the regression equation method. So, what do we do? In the case of the graphical method, we start by selecting the trees. So, we cannot put each and every tree, we need to find out the generalized trees. So, we will come to it in greater details later. So, once we have selected those trees and we have filled those trees, then we are going to take measurements of those trees, then plot the curves, use a number of checks and balances, and then get a table out of it. So, let us look at these steps one by one. So, when we talk about the selection of trees, we need trees with a typical height. So, for instance, if in your forest you have these trees say one more tree, and so here you have these trees of the same species in the same forest. So, what is the typical height? We can say that these, so if we write it as 1, 2, 3, 4 and 5. So, we have 5 trees here. So, if we figured out the average height or the typical height, it would be somewhere like this. So, we can say that tree number 1 and tree number 2 and tree number 5 are the typical trees, whereas this tree number 3 will not be selected for making our volume table because it has a greater height. The tree number 4 will also not be selected because it has a very small height. So, our trees have to be typical in height. So, coming back to the slides, so trees with typical height, they need to be evenly distributed. Why evenly distributed? Because suppose your trees were very close together. So, here we have, let us have, these trees are very close together. So, they are forming one canopy. If we measure these trees, so these will not be able to give us the values that we find in a typical forest. So, consider a forest in which you have mixed species. So, when we talk about mixed species, then we might have our trees separated from each other. So, this is one species, this is another species, this is our third species, say this is our fourth species. So, if we look at trees of one kind, suppose this tree, so here we have these trees that are separated from each other. So, if we took trees that are very closely distributed together, then these values might not be representative of the field situations, which is why we go for evenly distributed trees. So, coming back to the slides, so we need evenly distributed trees. These trees should not be having any sort of defect. So, for instance, if you selected those trees that were infested by insects, or say they were diseased trees, or say they had a huge amount of forking, so these trees are not the representative trees of the trees in a forest stand. Now, in the case of a volume table, remember that we are trying to get the averaged out values, and averages are very much affected by the outliers. So, for instance, if you had values say 15, 16, 15, 16, 15, 16, and if say one value was 200, so your average will be very much moved by the extreme values. So, which is why we want trees that are very typical. So, they will be perfect trees of a typical height that are spaced in a typical fashion. So, we are going to use the measurements of those trees only to derive our general volume table. So, coming back to the slides. So, how many trees are we going to select? So, this selection of the number of trees will depend on the precision that is required. So, precision that is required, so if you want more precision, you will go for more number of trees, and it will also depend on the deviation from the mean. So, for instance, if your values are very spread apart, so which is why we talked about the measures of central tendency and dispersion. So, for instance, if you have a distribution that goes like this, so just measuring these few number of trees will be able to get all sorts of variations that are typically found in the population. But on the other hand, suppose we had a distribution like this. So, because here we have a huge amount of deviation from the mean, so we will require more number of measurements or more number of trees that need to be selected. So, once we have selected those trees, so coming back to the slides now. So, once we have selected these typical trees, we are next going to plot our values. So, we will measure the diameters, we will measure the heights, and then we will plot a diameter versus height curve. So, now this curve is, here we have plotted some typical values for the case of sal. So, for different site qualities 1, 2, 3 and 4. So, as you can see, if you consider any particular diameter, say 40 centimeters diameter, so site quality 4 will give you a height that is around 33 meters, whereas site quality 1 will give you a very small height, and these are the most typical values, and these are the values that we calculated from the field. So, once you have gotten your values, you are going to plot these curves. Next, after you have your diameter height curve, you will read the average height for each diameter class. Coming back to these curves, when we talk about a diameter class, so what would be the height of your tree that has this diameter class of 20 to 30. So, you will figure out that height from the curve to get a typical height for each diameter class. Then you are going to calculate the volumes and plot the height versus volume curve. So, in this case, for each class we can calculate the volume. So, if we have the class mark and if we know the form factors, if we know the heights, we can find out the volumes. Once we have calculated the volumes, we can plot the height versus volume curve. Now, we are trying to get the most typical values. So, which is why we plotted the height versus volume curve and then we read the average volume for each height class. So, we know the average height for each diameter class, we know the average volume for each height class. So, next we are going to plot the diameter versus volume curve. So, here is one diameter versus volume curve. So, the volume goes on increasing at a slow rate in the beginning and then it is going to increase exponentially. So, this is the diameter versus volume curve. Once we have done that, we are going to read the values for each diameter class. So, now we know the typical heights for each diameter, we know the typical volumes for each height, we know the typical volumes for each diameter class. So, we can use all these values now to get our general volume table. Now, when we are preparing a general volume table, we need to take care of a number of checks and balances. So, for instance, the volumes of the individual trees should not deviate by a large amount. So, if we have selected our typical trees, so in that case the volumes of the individual trees will not vary a lot from each other. Then we can go for a height and diameter class check. So, for instance, once we have plotted that curve for typical heights for each diameter class, we can measure the heights of the individual trees and then check them against this curve whether our plot is correct or not. We can even have a relative check between two tables made from the same data. So, once you have calculated a huge amount of data, so for instance, if you had a large sized forest, if this is your forest area and we are getting one volume table from trees that have been extracted from this side and another table from this side. So, both these volume tables should give us values that are close together. If we have a huge amount of deviation, then maybe we have not selected our typical trees or maybe there has been some sort of calculation mistake. So, coming back to the slides, we also need to check the average deviations from the table. So, deviations for each tree from the final table will also be checked. So, that is the first way of calculating a general volume table. Now, remember your general volume table was giving you the volume as a function of the form factor, height, diameter and maybe some other variables. Another method in which that we can use to find out a general volume table is called the regression equation method. So, in the case of a regression equation method, so suppose we are using two variables, the diameter and the height. So, we can write these general formulae. So, like volume is a constant plus another constant multiplied by d square. Now, why d square? Because in the case of volume we will have say pi d square h by 4. So, in your volume is always going to vary as a variable of d square plus another constant multiplied by d square multiplied by height plus say another constant multiplied by h square plus say another constant multiplied by diameter into height square. So, you can write any sorts of regression equations. So, these are generalized equations and then we are going to try and fit our calculated values from the selected trees to our regression equation to get the all these constants. And once we have figured out those constants, then we can derive a volume table using these. So, we will have our diameter, height, and if you know our equation. So, the equation suppose it is a plus b d square plus c d square h plus let us call it capital D to differentiate it from our constant value. into h square plus whatever. So, if we are able to calculate our constants a, b, c, d and so on, so then we can use this equation with all these constants put in to derive a general volume table for each diameter and the height. So, that was about the general volume tables. How about the local volume tables? So, remember that a local volume table is derived from a general volume table. So, our general volume table gives us the volume of the tree by diameter and height classes. Now, when we want to get our local volume tables, we need our volume in terms of the diameter only. So, we can plot our general volume table figures to show volume against your diameter class mark for each height class. So, what we are trying to do here is, suppose we plot our values of the volume versus each dia class. So, suppose here are our dia classes. So, we are writing it against the class marks. So, suppose it is 15, 25, 35, 45, 55 and so on in centimeters. So, if we with our general volume tables we will have that for a 15 centimeter diameter we can have a volume say V1 for a particular height 1, then this for height 2, this is a value for height 3 and this is a value for height 4. So, this is height 4, height 3, height 2 and height 1. So, similarly we can find out these values for each of the different diameter classes. So, here we are marking the volumes for each diameter class for different heights. So, this is what we will get from the GVT. So, coming back to the slides. So, we are plotting our GVT figures to show the volume against the diameter class mark for each height class. Next, we will measure our trees and record diameter class wise their values to plot diameter versus height. So, now coming back to this to the tablet. So, what we are doing now is that for our particular location we are measuring the diameters and we are measuring the heights. So, suppose we get the heights like this. So, let us write it as a square. So, suppose these are the heights that we get. So, these are the heights that we have measured from our locality. So, coming back to the slides. So, now we are plotting the diameter versus height curve. So, what we are doing is coming back to the tablet now. So, this was volume and here we have the height. So, for this dia class we have this height, for this dia class we have this height and so on. So, coming back to the slides. Next we do to prepare the graph, a smooth curve is drawn through the plotted points which gives us a local volume curve. So, what we are doing is coming back to the tablet now, we are drawing a smooth curve from all these values of heights. Once we do that, we get a local volume curve, because for this diameter this would be the height and this would be the volume. So, this is the first volume. For this diameter class, this is the height and this is the volume V2. Similarly, here we have another volume V3, here we have another volume V4 and so on. So, this curve is called the local volume curve. So, coming back to the slides now. So, once we have drawn the local volume curve, it represents the local relationship between diameter, height and volume. Because we have drawn so in the tablet we have, coming back to the tablet, yeah. So, here we have drawn the diameter class versus volume and the height. So, we have drawn all these three values together and we have derived our curve, the smooth curve. So, coming back to the slides. Next, we use this curve to find and tabulate the volumes for each diameter class, and once we do that, we get the local volume table. So, what is the utility of these volume tables? One, they give us a quick way of assessing the volume of the standing trees. They are easy to use, there is no need for any other instruments or calculations, they are convenient to use, they have an ease of application in the field, they permit us simultaneous calculations for measurements. So, for instance, in the case of a log, if you measured its diameter, you will diameter and the length, you will directly be able to get the volume. So, we can directly write the volume values as such in our records. They are standard and precise ways of getting the values, but at the same time they also have a few limitations. They are based on averages, and your trees might not have the same volume as the average volume. They might be dependent on the locality. So, if you have say a local volume table for Kanpur, you might not be able to use it in Dehradun for instance, because your local volume tables will be locality dependent. They do not take into account aspect and altitude. So, for instance, if we considered a hill and suppose this is towards the south and this is towards the north. So, in the case of India, which is lying in the northern hemisphere, the sun is always towards the south. So, what it does is that this portion receives the sunlight, whereas the other portion is hidden from sunlight for the most part. How does that matter? Because this side is receiving sunlight, so here the temperatures will be higher, the humidity will be lower, whereas on the other side you will have reduced temperatures and higher humidities. So, essentially a tree that is growing here might appear very different from a tree that is growing here, but our volume tables, the generalized volume tables or the local volume tables are not taking care of this value of the aspect. So, this is what we call as the aspect of our site. At the same time, our local volume tables or the general volume tables do not also take care of the altitude. So, in the case of altitude, our tree growing here might be very different from a tree growing here, might be very different from a tree growing here, because as we are going up in the height, the temperature is reducing. At the same time, the amount of wind pressures that these trees will face might also vary as according to the height. So, our volume tables are not taking care of the aspect of the site and also the altitude of the site. So, in certain applications this might become a limitation. So, coming back to the slide, they are not accurate enough for research purposes, because remember we have only taken our typical trees and taken out averaged out values. So, they might not be accurate enough for research purposes. So, these are some limitations of the general and the local volume tables, but that being said, they play a very important role in the case of field forestry, because they permit us to get some computational values quickly and with ease without the need of many instruments. So, that is all for volume tables. Thank you for your attention. Jai Hind.